Applications of linear relations and distance time graphs. If you look, I have given you 3 distance time graphs. And I want you to look at them and think about, how does distance change over time? We think back to how we described a relationship like that a couple units ago. How will we describe the change in distance over time in each of the 3 graphs? And then how will we determine its rate of change of distance with respect to time? So we're going to describe distance, changes in distance over time, and we're going to determine the rate of change of distance with respect to time. Okay, so we're describing and we're finding a rate of change. If I think about this, let's look at the graph. What's happening? The distance is going up and the time is increasing. So if I were to write that, I could say as distance increases, so does the time. And of course, I've written that on the next slide, so it's neater. Now, if I want the rate of change, well, remember, rate of change is just a slope that's rise over run. Now, how do I think about that? The first thing I need to do is pick 2 nice points on the graph. And I'm going to go to the right, and I'm going to go up to get from one point to the next. And I went right 2 seconds and up 2 meters. Going right increases going right implies an increase, which is positive. Going up implies an increase, which is also positive. So if I go back to my rate of change, which is rise over run, my rise was 2 meters over 2 seconds, which reduces to 1 meter per second. And again, like I said, that's written really neatly here for you. In the next graph, what's happening there? If I look at my distance is never changing, is it? So my distance stays the same over time. So as the time increases, the distance stays the same. The rate of change, of course, I was doing the same things. I can highlight for key information and underline what I'm looking for. I'm describing the distance over time. I'm finding my rate of change. So to find my rate of change, that's my rise over run. Well, if I pick 2 nice points on this graph here, and I'm going from the point on the left to the point on the right, my rise was 0 meters. My run was 2 seconds. So rise is 0 meters divided by 2 seconds. And if I have nothing and I share it with 2, I'm giving each of them nothing. So my rate of change is 0 meters per second. Again, it's written neatly right here for you, so you can copy from this slide. Last one. What's happening to the distance? Distance starts off high and it goes down to 0. So the distance is decreasing as the time is increasing. And of course, I could highlight, but I already did that in the other questions, so I really don't need to keep doing it. I'm looking for my rate of change, which is rise over run. So again, I'm going to pick 2 nice points on my graph, one here, maybe one here. And I'm going to go down and to the right. And when I go down, I'm decreasing my value. So my rise is negative 3 meters. And my run went to the right, so my time was increasing. My run was 3 seconds. So my rise is minus 3 meters divided by my run, which is 3 seconds. So my rate of change is negative 1 meters per second. Well, what does it mean if that graph represented the motion of a person walking? That is, what is the person doing when the rate of change is 0, or the rate of change is positive, or the rate of change is negative? That's what we're going to see tomorrow in class. But before you come to class, you usually get to do homework. Today, you don't. You get a freebie. So we'll see you tomorrow.